If you come across questions which include the words how many different arrangements, combinations, permutations, teams, players, code, and sometimes large integer numbers in the answer choices, these are combinations questions. As mentioned previously, when asked which lecture they would like to see next, students will repeatedly specifically ask for combinations and probability. In other words, this topic is challenging. More specifically, these questions tend to appear more frequently as the questions become harder. Luckily for us, there is a phenomenal method which solves approximately 95% of all combinations questions and about 30% of all probability questions. It is helpful to remember this method using the mnemonic LOMO, which stands for lines, options, multiply, and order. Before we elaborate, let's first see how this excellent method rapidly solves this question. 3 lines, 1 for each stage, each with either A, B, or C. So 3 options per line. Multiplying 3 times 3 times 3 yields 27. The order matters. That's it. The correct answer choice is E. Let's elaborate. Since the question is asking us how many different codes are possible, and since it includes integers in the answer choices, unlike probability questions which will include fractions, this is a combinations question. Let's implement the method again, but slowly. Since this is the first combinations question, let's ensure that we review this method slowly and thoroughly. L is for lines. We need to indicate a line for each stage required in the question. How many stages are required in the question? 3, since this is a 3-letter code. We draw 3 lines. O is for options. Under each line, we indicate the relevant property, either A, B, or C, here, here, and here. Above each line, we indicate the number of suitable chronological options. Since the first letter may be either A, B, or C, the number of suitable options here is 3. What about the second stage? Were we told that the letters need to be different from one another? No. In other words, chronologically, after we considered the first letter, as we arrive at selecting the second letter, we still have 3 options from which to choose: A, B, or C. The same goes for the remaining stage. Remember that as you select the items, you need to actively ask yourself, does the total number of options remain the same, or does it decrease by 1? The total number of options usually remains the same, for example, in questions which include letters, since letters can appear at 2 different locations at the same time. They can be reused, as was the case here. For example, even though it includes the letter A twice, the code AAB fits the question's conditions. In mathematical terms, this question is with repetition, since as we select the items, we can repeat our former selections and the total number of options remains the same, 3 per line. The total number of options decreases, for example, in questions which deal with people, since a person cannot appear in 2 different places at the same time. In mathematical terms, such questions are without repetition, since as we select the items, we cannot repeat our former selections, and the total number of options decreases. More on that later. M stands for multiplication. What do we do now? We multiply the various options. 3 times 3 times 3 is 27. O stands for order. Finally, with combinations questions, remember to always ask yourself whether the order by which you selected the items matters. For example, is an ABA code the same as a BAA code? Of course not. The code ABA might be the right code to open the lock, whereas the code BAA will not open the lock. Whenever we create codes, the order matters. Since the order does matter, we've reached the correct answer. The correct answer choice is E. We'll elaborate as to what happens when the order does not matter a bit later on. Before we move on to the next question, some of you may wonder, why do we multiply rather than add, for example? Let's assume we would have been asked to form only a 2-letter code using A, B, or C here and A, B, or C here. How many codes would have been possible given this scenario? These would either be AA, AB, AC, BA, BB, BC, or CA, CB, CC. 9 options in total. So from 3 options and 3 options, we get to 9 options. How do we get from 3 and 3 to 9? By multiplying. In combinations, and equals multiplication. What if we were asked to choose either one of the letters A, B, or C, or either one of the numbers 1, 2, or 3? How many options would have been possible given this scenario? We could either choose A, 3, B, C, 1, or 2. 6 options in total. So from 3 options or 3 options, we get to 6 options. How do we go from 3 or 3 to 6? By adding. In combinations, or equals addition. By the way, it should be noted that and equals multiplication and or equals addition in both combinations and probability, since these 2 question types are quite similar. Finally, as you may have noticed, combinations and probability questions can sometimes be slightly tricky, so it is important that we work slowly, methodically, and chronologically. Before moving on to the other questions, ensure that you've memorized the combinations method using the mnemonic LOMO: lines, options, multiply, order. Feel free to rewatch the video.